In this video, I want to show the second part of the if theorem. So I need to show that if the invariant holds and the guard for the loop holds and the first guard holds, that implies the weakest precondition of the command corresponding to the first guard, the invariant again. The command is an assignment, so I need to do a textual substitution. Everywhere I see a y, I will replace it with y minus x into the invariant. And then I need to look at what I have. Notice from useful facts of GCD, that I can simplify the GCD of x, y minus x is the same as the GCD of x, y. I also notice that I can simplify this interval. I have 0 is less than y minus x is less than or equal to y hat. I could add x to the inequality, and I find I could write that as y is between x and y hat plus x. Now, if I instantiate the invariant and the guards, I find that the guards actually simplify. One of the guards for the loop is x is not equal to y, and the guard for the if is x is less than y. X not equal to y and x less than y simplifies to x is less than y. So if I now look at what I have, it seems like if I look at the sub-expressions on both sides of the implication, there is a lot of commonality. And the inequality can be broken into x is less than y is less than or equal to y hat, or y is between y hat and y hat plus x. So that's one of the things that I did. And I looked at the two expressions I have on both sides of the implication and noticed the commonality. There are a lot of them. As far as the intervals go, for the stronger side, it's 0 is less than x is less than or equal to x hat, and 0 is less than y is less than or equal to y hat, and x is less than y. Versus the other side, I have 0 is less than x is less than or equal to x hat, and 0 is less than x, which is less than y, which is less than y hat. So there's commonality there. But on the weaker side, I also have or y is less than or equal to y hat plus x. I notice that it's not just a simple or. If I use distributivity, I have a much longer expression that I'd have to deal with, but I still notice that there is a lot of commonality, and I can think of this in terms of P implies P or some other stuff, which is R. I could describe as R. So by weakening and strengthening, this extremely long expression I have to deal with is true. I know it's true. So that is my proof for the second part of the if.